All right, so what I'm going to do is go over my copy of this. There aren't a lot of comments in here. I didn't put a prologue at the beginning. I'm taking for granted you all know how to play the game, etc. So let's just go over what I did. And again, I don't know if you've ever heard the term verbose. That's what this program is. It could have been cut down quite a bit, but I just wanted to show you what I did. All right, I kept rewriting it while I was doing it. But one thing I wanted to do was I got it to work, but after a while it was saying something like user chooses 1, computer chooses 2, winner is 2. That isn't very helpful. And then you're constantly having to sit there and say, okay, no, wait, 1 was rock, etc. All right, so all I did was I equated rock, paper, and scissors with 1, 2, and 3. Now hopefully that makes sense. All right. Then at the end, I wanted to say either the computer won or the user won. Well, that was these two right here. And then to show that the games were, that there was a tie, I did this. What that ended up doing is, as you look through this, is it made the program again more English-like. All right. Using constants like that provided more internal documentation. All right. When you do this test tomorrow, all right, you do not, all of these constants are global because they're at the top of the program. I'd suggest you do that too. Tomorrow you can make all of your variables global. I would suggest you do that because then you don't have to worry about passing things around. Once we get into chapters 7 and 8, so starting this week on Thursday, we're going into chapter 6, which is on arrays. Then next week we're going to do chapter 7 and chapter 8. That's on methods and being able to pass things around to the program. At that time, then you're not going to be able to do this and make everything global like we are right now. So you might as well take advantage of it while you can. All right. Now hopefully just taking a quick look here, looking at my variables that you see right here, hopefully those variable names make sense. Right, user choice, computer choice, winner, ties, user wins, computer wins, play again, and the winner. Just looking at that, like I said, hopefully that makes sense to you. So this, where it says the winner, where it's going to say either tie, user, or computer, that's going to be this, or this, or this. Okay? So this whole thing right there, everything that you see in front of you on the screen right here, that's main. So main is just a driver. Ideally, that's what we're going to shoot for in our console programs. All right, that main is a driver like this. So I've got this variable that I call play again that I set equal to true. I assume you want to play at least one game, otherwise, why were you running the program? So again, this is a shortcut for while play again equal true. So as long as I want to keep playing a game, again, I tried to come up with names here that were reflective of what it was I was trying to do. All right, so the first one, determine computer choice. The second one, determine user choice. The third one, determine winner. Then display all, and then do you want to play again? All right, like I said, I couldn't think of doing it in a way where the names were more reflective of what it was I was trying to do. When you do this test tomorrow, the first problem you do probably is easier than this one, but it's more on this side. All right, where you're going to create something very simplistic like this. If you use whether you use a console program or whether you do a GUI program, for both of them, I'm going to check and make sure you use good variable names. And for the console program or programs that you do, I want you to do what I've been telling you. That is, all right, set the cancel button, set the accept button if you have both of those. All right, so if you have 2 or more buttons, set the tab order. Set the Windows start position. Have the background color be something that at least looks decent. All right, so it's easy to read. Does all that stuff make sense? All right? You should be at the point right now where you can not only make an interface, but you can make at least a somewhat aesthetically pleasing interface. All right? I don't want you to go too nuts on it. I'm literally saying, with the stuff I just told you, 5 to 10 minutes max on each one of the programs to do the interface. Hopefully closer to 5. All right? All right, then once we fall out of the loop, so you'll notice here that I only print out the final totals. That is the number of tie games, or the number of games played, the number of tie games, the number of computer wins, and the number of user wins. I only print that outside when I say I don't want to play anymore. Does that make sense? So if you're asked to do something like that tomorrow, hopefully you can do the same thing. All right? All right. Now, one word we haven't talked real much about, if you notice in here, you may or may not have ever noticed this before, but this is pretty standard for a main. And we've talked about the fact that the name of the routine is main. All right? That if we want to, we can pass things into main. If we do, this is what we're going to go over in Chapter 6. This says that it's an array of strings. The bracket means that it's an array of strings, and it's called args. You don't have to worry about that. This says main doesn't return anything. All right? This says, for right now, for lack of better words, there's only one of them. All right? Well, the point is, when you do static stuff in main, everything that touches that static stuff as far as variables has to be static too. All right? So if I leave off, for instance, in here, if I leave off the static, I'm going to end up, maybe not right away, but sooner or later, I'm going to get an error. And it's going to tell me that it doesn't understand what it is I'm trying to do. All right? So I come in here. This should be pretty darn simple right there. This function determines the computer choice. That says, give me a random number between 1 and 3. All right? 1 is going to represent rock. 2 is going to represent paper. 3 is going to represent scissors. How did I know how to do that? I Googled creating a random number in C#. Because I do it in a bunch of different languages and I forget. And it's not done exactly the same way in every language. Some languages only have a random function. All right? Not a random.next like this where it does integers. With some languages, it has a random function where literally it generates a number that's greater than or equal to 0, but is less than 1. Then you've got to convert it to an integer. You've got to like multiply it. Let's say I wanted a number between 1 and 100. Then you've got to multiply it by 100. That'll give you a number between 0 and 99. So you have to add 1 to it, and then you have to use the integer portion. All right, so every language is different in how it handles this stuff. But as it says, this function determines the computer choice. All right, so the choice that it is the computer can only choose 1, 2, or 3. The good news is the computer can't screw up. The bad news is you sure as hell can. And if somebody's playing the game, we want to be able to handle it. So if you look here, here's the, everybody see this line? That clears your screen. So every time I'm playing a new game, I do a console.clear to start. Okay? Now, I believe that in order to do that, you need this line, this using static system.console, but I don't remember if it needs it or not. I don't care. But if you want to clear the screen, console.clear. That's all you've got to do. All right. So now I come in here and I tell the user, the computer is chosen. Now it's your turn. All right. I didn't put a lot of checks in here. All I checked for was I said, if it's not a 1 and it's not a 2 and it's not a 3, just put it up again. Does that make sense? The problem is if I put hello in there or I leave it blank, the program in its current form blows up. We've already talked about how to make sure it doesn't blow up by using that try parse. You've done that before. All right, you have done that before on at least one of those payroll programs. It may be in your best interest, and when you take a test, you got to take it whatever the heck way makes sense for you. But you may want to have one or more hard copies of different assignments or whatever available. You might want to have, remember, you can have as many Visual Studios open as you want to or need to. I wouldn't have 7 or 8 of them open because you're going to get confused going back and forth. But if you want, the last couple payroll programs or something open, then that's what you should do. All right, so while the user does not, the user's choice is not a 1 and it's not a 2 and it's not a 3. Some of you have had questions about this stuff. You have asked me. You have said, wait a minute, why did you make yours an and? Shouldn't that be an or? Well, in this case, if I made that an or, it would allow you to put in anything. I only want to give them an error message if they didn't put in a 1, they didn't put in a 2, they didn't put in a 3. Does that make sense? All right. So I'm saying it's not 1 and it's not 2 and it's not 3, which means they put in something other than a 1, 2, or 3. All right. So if they do that, I just put error and I repeat the exact same stuff I had here, except I don't use the int right there. And I try to convert it. But again, I showed you this before, or I said this before, but if I leave it blank and hit enter, the program now blows up. Because I put something that was non-numeric and I'm trying to take it and I'm trying to convert it into an int. That's why it blows up. So again, we could have used that try parse. I just didn't do it. All right. So by the time we get done with this and with this, I know what the computer has chosen. I know what the user has chosen. It really doesn't matter here which one of these I put first. Does that make sense? Because for lack of better words, I'm kind of doing it invisibly because all I'm doing is returning that number and I haven't checked yet to see what that number was. I mean, if I wanted to be an ass and write a really stupid game, I could have the computer choose first, I could print out the computer's choice, and then I could always win. All right? I could be Tom Brady, for lack of better words. All right. So I come in here now, and I'm determining the winner. This was a lot bigger than it had to be. Again, this was a lot bigger than it had to be. I've replicated some stuff, but I tried to set it up in a way that was going to be so obvious as to what was going on that it would make sense to you. That was my rationale behind it. All right. So I already know this was the easiest. If the user choice equals the computer choice, I don't have to check anything else. This is the kind of thing that you should be, maybe it's, oh, geez, I never thought of that. But you have to start thinking about it. All right, you have to start thinking about, is there a way when I'm writing this application that I can make it a little bit easier for the computer? And you might listen to that and go, why would I want to make it easier for the computer? Because quite often when you're writing an application, if you go to work for a company, and let's say you go to work for Amazon, all right, and you're working in their system that's creating, all their pretty web pages and everything else. If you can figure out a way that you can make it faster for them, you're going to be remembered in a good way. Does that make sense? They've got literally, right now, if I go, I'm not going out to Amazon, but if I did, there's probably at least 1 million people on there right now. And that's probably a low estimate. But if I could cut that time down by 10% or whatever percent, they're going to like that. So, when people hear that, well, I don't understand why you're making it easier for the computer. Because the computer already has enough to do. Maybe not your computer, all right, if it's just you running it and playing the game. I get that. But think about it if we tried to take this and put it onto our phone. All right? Even if you only don't have a lot of stuff running on your phone's got a lot less limited screen space. It's got a battery you got to worry about. It's got less RAM in it that you've got to worry about, etc. All right? So, if the choices were the same, I add 1 to ties, and this variable called who won, I set it equal to tie. And it looks like, wait a minute, you're setting it equal to a string. No, I'm not, because tie up above was set to 0. All right, otherwise, and I put a huge switch in here. So in this case, the computer chose rock. What does that mean? I know the user didn't choose rock, right? Because we already checked for ties. So all I have to check for is rock, paper, and rock, scissors. I know if it's rock, paper, all right, I know the user won because rock, paper covers rock. So who won? That's 5. 5 is equal to user. Otherwise, if it's scissors, I know the computer won. So I add 1 to computer wins, and I set who won equal to 4, which is the word computer. All right? And then I get the hell out. Well, if it's not rock, then I have to do the same kind of check for paper. And if it's not paper, I have to do the same kind of check for scissors. If for some reason I get into this, and this should never, ever possibly be hit, but if it does, I just set who won equal to a tie, and I get out. I don't do anything else. All right? In much the same way, if you look up here, notice what I'm doing here. I'm just going to grab the rock one. If user is paper, if user is scissors. I don't even have another else in here. I have an if and an else if. So if somehow the user is, the computer is rock and the user is not paper or scissors, I'm not doing anything. I don't want to. I've already handled if they're both the same, and if it's something else, that game shouldn't be counted anyway. All right, so that's the way I chose to handle it, rather. All right, then I've got this one, and as it says, display all. This prints out the current game info, the computer choice, the user choice, and the winner. Now, notice, hopefully, when you look in here, how much more English-like it looks. So rather than saying if computer choice equal 1, I can say if it equals rock. This is a number right here. That's the number 1. That's the string ROCK. Does that make sense to everybody? All right. You know, in the same way, the number 2, the string PAPER, the number 3, the string SCISSORS. All right. So I check all this stuff. I check the computer choice and I check the user choice. All right, and then I start working with the winner. Why? That meant that when I did this, I can say the computer picked rock, the user picked rock, and the winner is tie, no winner. All right? That's the kind of thing you should be striving for. You know, I've said this before, and sometimes people laugh, and I don't mean to be funny. All right? Assume the person using your program, not that they're an idiot, but assume they're ignorant. There's a difference between being an idiot and being ignorant. All right? Typically, ignorance can be cured. If somebody's an idiot, it's typically a lot harder to cure them. But sometimes when people are ignorant, they just don't know. So I'm assuming here that by making it as English-like as we possibly can, that the person can understand what it is we're trying to do. Does that make sense? All right. And then we've got this here. This was, do you want to play again or not? So play another. First chart, do you want to play another game? Please look at this. Have we really talked a lot about different things that you can do with strings? No. But in English, what that does, so it comes up and on the screen it says this line right here. So imagine you've got, this is your screen. You get a statement that comes up that says, do you want, etc. All that other good stuff. And then right here, you're supposed to put in an answer. All right? So I type in yes. Even though it says Y or N, I'm ignorant, so I type in yes. So this says, start with the first character and only go one character, check that one. And then uppercase it. So if I put in here this, then what it checks is that. All right? then I only have to check this. If I didn't do that, if I didn't do something like what I'm showing you right here, then I'd have to say something like, if first char equal yes, or first char equal a little y. All right. Plus, if you notice, this isn't a char, that's a string value. Why? Because I can only run a substring function on a string. So again, trying to make it easier, or as easy as I thought I could for the program. Okay? Now you could argue here, I mean, again, I'm trying to show you things as I think of them. I could have come up here and I could have done this. Sometimes you'll see this, that a user will write, in fact, I'll just write it up here. They'll write Boolean, or bool, ret val, that stands for return val, and I'm going to set it equal to true. All right? So, if this is the case, I don't have to do anything. But I could come up here then and I could say, if it's not equal to y, then I could have said ret val equal false. Then down here I could have just said return ret val. The reason I'm showing you that is many programmers would tell you that's a better way of writing it because there's only one return statement. If there's only one return statement in the program and you're having problems with the program, you know exactly where to go. All right? I'll tell you what, I worked with a lot of poor programmers when I was a professional programmer. And there were different functions that I had to go into. Literally, there would be 100 different places in the function you could return from. And I'm not exaggerating. And then there'd be a problem, and you'd have to sit there and dig your way through it, and it was a pain in the ass. Whereas if they'd have done something like this, it would have made it easier to figure out what was happening. I'm not saying that that cures all your problems. It doesn't at all. But it makes it easier to handle. That's all I'm saying. All right. And this just printed out the totals. Questions? I mean, if there is something that doesn't make sense, please ask. I'll try to remember to do that before the test tomorrow. What I did for your test tomorrow, it's 4 pages. Now, don't let that throw you, because 2 of the pages, I actually did dumps of the kind of thing I'm looking for, so they're screenshots. All right? I figured that might be easier for you. But since I'm trying to save paper, I'm going to give you a dump, but I'm going to give you the things. But the first page is going to have, like on here, on the front here, it'll have the instructions. And then on the back, when you turn it over, it'll have the screenshot. Then the second page will have the instructions, and you turn it over, and it'll have the screenshot. All right? And one of the things that we are mandated to do here at Rankin is to create a rubric. So, in other words, on every question, you're going to see the exact points that question is worth. Now, you might look at it and say, well, I'm not going to do this one. It's only worth 5 points. Okay. But sometimes, if you don't do that first step, all the stuff you try doing later won't work because you didn't do the first step. All right. I would suggest that you go down and do it kind of in the order I put it in. That's the order that I did it in. Now, if all of you are here tomorrow, then I will do my darndest to get it graded tomorrow, all right, by the end of the day. And then before we start Chapter 6 on Thursday, we'll go over it. All right, I'll give it back to you. If anybody misses, that's not going to happen. I'll just tell you that right now. I might have time to grade them, but I'm not giving them back. All right, I've had this happen in my second year class. I've got one of my students, she has childcare issues. She didn't make the test yesterday. And I got all these students, did you get the test graded? No. Are you going to go over it today in class? No. Why? Because somebody missed class. All right? And the reason I'm saying that is just so you know, that's not a threat. All right? I think I've told you this before. You know, Mr. Corrigan over there, his policy is anytime he gives a test, if you miss, he doesn't care what the reason is. Unless you have a doctor's excuse or you've cleared it with him ahead of time, it's a 0. You cannot make it up. That's just his policy. I'm trying not to be that strict. All right? If we have to overtime, I'm going to end up being that strict. All right? There are 3 of you in here right now who are wearing jackets that are not Rankin jackets. No, you laugh. If he sees any of you walking out with those on, or if he walks by here, I get called in, and he closes the door, and he spends 5 minutes with me, and he's like, Jeff, you know what the Rankin policy is. And I'm like, yes, I do, Charles, and I keep telling them. All right, he's like, well, then what I'm supposed to do is, in 10 days, I think today was day 11, 9 days from now, I have to meet with each one of you and give you that work ethic grade. So if you continue to do that, you lose work ethic grade points. All right? And I'm not trying to be a hard ass. I'm just being honest with you. He got on me last semester because I had a female student 3 times. She had her nose ring in. He was like, and then Shannon saw it. That was the worst. Okay? Last thing I want to tell you, because I'm done, just so you're aware of this. A week from Friday, which is February 2nd, what's going to happen is I am taking 4 of the second-year students to St. Louis because they're competing in the Skills USA contest. All right, there's 2 of them are doing the programming, 2 of them are doing the web design. Charles is having a lab that day. He will take attendance. He's going to open up the area between these 2 rooms. I guarantee you it will be lab. If you miss, you know, it's like you missed any other day. But I'm letting you know that ahead of time. So no matter how it works next week, Friday will be a lab. All right? No questions? All right. I will try to remember to ask if there are questions before I give the test out tomorrow. All right? Again, open book, open notes, as it has been.